Okay, now for the second subtopic is double integral in polar coordinates. Okay, so why we introduce double integral in polar coordinates? When you have a shaded region or region in circular type shape, so it will be easier to solve the double integral by using polar coordinates. Okay, for this kind of region. Okay, so let's recall whatever that you have learned on polar in engineering mathematics 1. Okay, I believe that you already learned about it. Okay, so it's just to refresh back on how to convert from Cartesian to polar coordinates. Okay, so x is equal to r cos theta, y equal to r sin theta. Okay, so we have in this form. Okay, so another parts that is not included here is how to find the angle here by using tangent. So tangent theta is equal to y over x. So the values of theta is equal to inverse tangent y over x. Okay, so I believe that you still remember, okay, the basic idea on polar coordinates. Okay, so in Cartesian, okay, in Cartesian that we learned that we have two orders. Okay, dA can be either dy dx or dy dx or dx dy. Okay, however in polar coordinates, okay, so dA is only focusing on one type only. Okay, r dr d theta. So whenever we have in this form, means that limit for theta must be constant or fixed. Okay, means that we also have in the form of r d theta dr actually. Okay, but in your content, we only focusing on this one type only. Okay, focusing on this type only, whereas we have r dr d theta. Make sure that you do not miss r here. Okay, so whenever you have circular type shape, okay, so it will be easier to solve using polar coordinate instead of Cartesian coordinates. But you can also solve the circular type question by using Cartesian coordinate, but will be a little bit hard compared to when you choose to solve using polar coordinates. Okay, so how to determine the limit? Okay, you should always remember two things. Okay, so the angle is move anti-clockwise. Okay, so let's say if we have a shaded region like this, okay, means that this one is start with 0 right up to here. Okay, pi over 2 right, so means that the limit is 0 up to pi over 2 like this. Okay, so let's say if in this part, okay, in this part means that this one is pi up to 3 pi over 2. Okay, it's not like 3 pi over 2 up to pi because it's anti-clockwise. So the limit for here is from pi to 3 pi over 2. Okay, r measured from pole outwards. Okay, so let's say if we have a shape like this, okay, outward means that this one, let's say this value is 2. Okay, so the values of r is here. Okay, move from pole outward. Okay, so means that is r equal to 2. Okay, so here is r equal to 0, so the limit is 0 up to 2. Okay, so this is two things that you should remember when we are dealing with polar coordinates. Okay, so this is, I believe that you already learned about on common polar equation. Okay, so this is the common polar equation. So whenever you have the shape is the center is on 0 0, so the values of r is equal to the values here. Okay, but whenever we have the shape or the circle is on this side is equal to b cos theta. Okay, if is on positive y is equal to b sin theta. Okay, so let's say if this one is at center is 1, so actually the equation for this circle is x minus 1 squared plus y squared equal to 2. Okay, equal to 2, no, equal to 1 here, because there is, if we set this one is 1, this one is 2. Okay, so for here actually is x square plus y minus 1 squared equal to 1. Okay, so if like this, means that this one is equal to sin theta, so this one is 2 cos theta. Okay, so this is the basic or the common polar equation that you have learned previously. Okay, refresh back on whatever that you have learned on Engineering Mathematics 1. Okay, so let's practice determining the limits R is provided. Okay, so let's say for these cases. Okay, so here we know that the radius is 2, right? So here, if like to write the limits, okay, so this one is 0, right? So this one is up to pi over 2, means that the limit for theta for the first one is 0 up to pi over 2. What about for the radius? So the radius is from here is r equal to 0, right? Okay, so here, so r equal to 2. Okay, so this is the limit for this shaded region. What about this one? Okay, so for this one, the circle is, the radius for this circle is still 2. Okay, but we change into the different quadrant. Okay, so here is the limit for r still maintained. Okay, 0 up to 2. How about what about the limit for theta? So here since this anti-clockwise, right, from here up to here. Okay, so the limit is start at pi over 2 up to pi. Okay, so what about in these cases? So in these cases, so now we have the radius now is 3. Okay, but what about the angle here? So this one is counterclockwise, right? Start from here up to here. Okay, so means that pi up to 2 pi. Okay, so the new limit for this one is limit for r is 0 up to 3. Okay, since the radius is 3. Okay, so the limit for the angle is pi up to 2 pi. Okay, so what about these cases? Okay, these cases is still a circle with a radius equal to 3, but the difference is on the shaded region. Okay, so now for this part, okay, so since as I mentioned, that it should be anti-clockwise, right? Okay, so if we take from here up to here, so it's not suitable, right? Okay, so means for this part, we should start from here up to here. Okay, so now we know that this one is 0, right? This one is pi over 2. This one is pi, and this one should be 3 pi over 2. But if we like to in this one, it will be easier if we take the limit somewhere like 0 up to 3 here. So the limit should be negative pi over 2 up to pi over 2. Okay, so negative pi over 2 up to pi over 2. It will be easier to take into this form. Okay, because if you take 3 pi over 2 up to pi over 2, means that this one is not complete with one circle, right? Okay, so that's why we have to take negative pi over 2 up to pi over 2. Okay, because it's only considered for two quadrant only, this quadrant and this quadrant. Okay, so what about in these cases? Okay, so in these cases, we know that this one is okay, so since this one we consider for whole quadrant. Okay, so we know that the limit for theta is 0 up to 2 pi, because we consider for all quadrant, right? What about the limit for r here? Okay, so the limit, like I mentioned, the limit when we want to consider for the limit for r, it should move outward. Okay, so it's somewhere here up to here, right? So here start with r equal to 1, because of this one is circle r equal to 1. So start with 1 up to 3 here. Okay, do not confuse. It's not start with 0, because if 0 start with from here, right? But this one, the shaded region, start with up to this one. Okay, that's why we take r equal to 1 up to 3, because of this one is a circle with 3, radius 3. Okay, okay, so this one, what about this one? Okay, so for this one, okay, so this is also a circle. Okay, a circle for this one. So since this one is only in the first quadrant, okay, so we know that the limit for in the first quadrant should be start with 0 up to pi over 2, right? Because it is in the first quadrant. What about the limit for r here? Okay, so obviously start with 0, but with what? Okay, so this is the common, right? For this one, r equal to b cos theta. Okay, so the values of b should be this one. So this one is for cos theta. Okay, straight away based on the common polar equation. What about this one? Okay, so this one, the angle for this one is pi over 2 up to pi. Okay, so this one should be pi over 2 up to pi for the limit for theta. What about for r here? Okay, so this is the common shape for r equal to b sin theta. So here b is equal to 2, so r equal to 2 sin theta. So it should start with 0 up to 2 sin theta. Okay, so make sure that you know the region first. Okay, knows the region first. Okay, and after that you identify the limit for each for theta and also for r. Okay, so make sure that you remember these two things. Okay, theta should move anti-clockwise and r measured from pole, which is outward. Okay, and then please make sure that you remember this common polar equation so that you don't have to derive by your own. Okay, but actually if you got an equation for that circle, you can also get into this form. Okay, so I will show in the examples later on in the next video. Okay, so that's all for this video. Thank you.